I'm Jim White. I do ice core work in Greenland. It's a cold place. It's windy. It's not terribly inviting on the surface, but it's extremely inviting from the kind of materials you can get from what's underneath your feet. We drill ice cores. It's about 4 meters at a time. They're taken into a separate processing lab where we cut them up. We partition samples for things like greenhouse gases, for measurements like chemistry, for stable isotopes, which is what I do. Ice cores are really cool. They're unique in that they not only record the environment of where they are, but they also record the atmosphere. 10% of ice is air. And so we can take that ice back to the lab, crush it up, and release the gases and measure CO2 levels, methane, nitrous oxide. So we not only get the climate and the environment of an area, but we also get a record of those things that change climate. Things like how much greenhouse gas there is, things like changes in the sun. We can measure isotopes like beryllium that tell us about how the sun was behaving in the past. So the major drivers of climate on the planet are how much energy we get from the sun, how much ice is out there, and greenhouse gases. And we can get records of all three of those from ice cores. I think one of the most important pieces of information that we've ever gathered from ice cores has been the relationship between greenhouse gas levels and climate on the planet. Because we can measure greenhouse gases in that air within ice cores, we can show that there's a very, very tight relationship between how much CO2 and methane and nitrous oxide are in the atmosphere and the climate of the planet. That helps us to not only understand the relationship between greenhouse gases and climate, but it quantifies it. We know, for example, that during glacial periods when the Earth was much colder, CO2 levels were about 180 parts per million. During interglacial periods in the last million years, CO2 levels have been 280 parts per million. And so it makes it very important that when a few years ago we exceeded 380 parts per million of CO2 in the atmosphere, we understand that our impact on the planet is not small, that it is indeed very significant, and that we are facing some very significant climate changes in the future from our actions.